Hi everyone, my name is Ana Jorge Sobrido. I'm a senior lecturer at Queen Mary in the School of Engineering and Material Science. I'm also the program director of Sustainable Energy Engineering. What I do in my research is develop, design and develop sustainable materials that will find applications in energy devices, so particularly energy storage and energy conversion. So what we look into in our research group is to try to develop materials that come from biomass waste. So we're actually taking something that it's essentially rubbish and giving it another life. So valorizing the materials into products that will have an impact. So the materials, as I was mentioning, that we produce in our lab, will have impact in the climate change and hopefully in trying to develop and use more renewable energies. So at the moment, one of the things that our society really needs to fight against is to try to decarbonize our electricity. In order to do that, we need to be able to use more renewable energy resources. And in order to do that, we need to be able to develop devices that can effectively store the energy of solar energy or wind energy when the sun is not shining on the wind is not blowing. So in order to do that, what we do in our labs is to produce materials that are going to be high performing for storing this energy, so we can use it in a small scale in lithium-ion batteries, for example, but also in a large scale connected to the grid, so we can use it to store huge amounts of energy from solar, from wind, for example. One example of the materials that we design here and the processing techniques that we use is the machine that I have behind me, which is an electrospinner. We are able to produce mats of freestanding fibers that then we will use to in energy devices, say batteries, for example. So by doing that, we're able to process something that biomass waste into materials that can effectively being implemented and assembled into energy storage devices. Right. So as you can see here, this is a type of fibers that we can achieve with the electrospinning machine. We can achieve up to 35 by 35 centimeters mats of this style, and then what we do is carbonize them so we can enhance electronic properties, and then so we can use it as an electrode. So one of the applications of this type of materials is in redox flow batteries. What they're doing is trying to enhance the properties of these electrodes by modifying the surface, the chemistry, the porosity, the morphology, and the thickness of these fibers to optimize the efficiency and make them high performing for flow batteries. So the way that flow batteries work is by flowing an electrolyte that contains active species that are going to do undergoing redox reactions, so reduction and oxidation. By that means, we can store the chemical energy, but so we can use it later on. So redox flow batteries find application mainly in large scale energy storage, so grid scale. This means that they will be connected next to solar farms or wind farms, so they can achieve stored huge amounts of energy